In our next problem, we'll determine what angle of rotation would eliminate the x prime y prime term in a rotated x prime y prime system. So we have the equation 7x squared minus 6 times the square root of 3xy plus 13y squared minus 6 equals 0. So we need to determine the angle of rotation because of the xy term. So this is an equation of the form ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. And we can identify what our a, b, and c are. Our a is the coefficient of x squared, which is 7. b is the coefficient of the xy term, which is negative 6 times the square root of 3. And c is the coefficient of the y squared term, which is 13. And in order to determine the angle of rotation, we need to use the formula the cotangent of 2 theta is equal to a minus c over b. So in this case, the cotangent of 2 theta is equal to a, which is 7, minus c, which is 13, over b, which is negative 6 times the square root of 3. So we have cotangent of 2 theta is equal to negative 6 over negative 6 root 3, or we can simplify this to cotangent of 2 theta is equal to 1 over the square root of 3. So we need to determine what angle this represents. What angle is theta? Well, let's use a right triangle. Since our angle is positive, we'll draw it in the first quadrant. We have a special right triangle, the 1, 2, square root of 3 triangle. Remember, the cotangent of any angle is always represented by the x value over the y value. In general, the cotangent of an angle alpha is just x over y. So the x value is 1 and the y value is the square root of 3. So I'll draw a triangle where my x value is 1 and my y value is the square root of 3. This is a special 1, 2, square root of 3 triangle, and this angle in here, opposite from the square root of 3, would be a 60-degree angle. So, therefore, we know that 2 theta would be equal to 60 degrees. Dividing both sides by 2 gives us our answer that theta equals 30 degrees. In other words, we would have to use an angle of rotation of 30 degrees to eliminate the x prime y prime term.